Okay. Well, I'd like to welcome everyone to our panel discussion on global lessons from the thawing Arctic. We're hosted here today by the AAAS, the American Association for the Advancement of Science. And the panel discussion is sponsored by SEARCH, the study of environmental Arctic change. SEARCH is a collaborative program of Arctic researchers, funding agencies, including the National Science Foundation, and others that facilitates the synthesis of Arctic science, communicates our current understanding in order to help society respond to the rapidly changing Arctic. And you'll hear about some of these rapid changes today, with an emphasis on their wider effects. That is, they're not just what's changing in the Arctic, but why Arctic change matters to us all, well beyond the Arctic regions themselves. So, just as an introduction, my own work as an Arctic-focused sociologist includes survey research on what the general U.S. public knows and perceives about the polar regions. And honestly, their knowledge is quite limited. On a survey we ran last year, it turned out that only about 18% of Americans realize that the United States has territory and thousands of people living in the Arctic. And a majority are confused about many other really basic facts as well, including the location of the North Pole. However, 69% know that Arctic sea ice covers less area today than it did 30 years ago. So there are some facts that are being communicated, even without the basic geography. People know that the Arctic ice is melting. They may not understand the connection between Arctic sea ice and Arctic land ice and what either of those has to do with sea level. But they do have this fact that the Arctic ice is melting. And interestingly, they perceive a global connection from that more than 60% believe that Arctic warming in the future will have major effects on the weather where they live. Now we're going to be talking about these global connections today with our panelists. And our first speaker, I'll just go ahead straight to the presentations. Dr. Christina Shadle of Northern Arizona University. She will be talking about permafrost, a perhaps to some people unfamiliar Arctic phenomenon that nevertheless could have substantial implications for the world's atmosphere.
Good afternoon. What do you think does Alaska have in common with Washington, D.C.? So I can tell you it's that we all share the same atmosphere. So if greenhouse gas release in Alaska, in the remote state of Alaska or other places of the Arctic is increasing, it actually has a direct impact on people living in Washington, D.C. and other places in this world. What you see in this picture here is permafrost, which is by definition frozen ground for 2 consecutive years and longer. And usually you don't really see permafrost because it's underground, so you stand on top of it maybe, but there's vegetation over it, or snow, and so you don't really have access to it visually. But in this case, this is an eroding hill slope, so you see that there is soil, which is mixed in with really big wedges of ice. Part of permafrost contains a lot of ice, other parts of permafrost contain very little ice, and that can have really big implications as well. And one thing to note is permafrost thaws, it does not melt. It's only the ice in permafrost that melts. And permafrost is distributed in the northern hemisphere and also other places in the world. What you see in this map is a circumpolar view. So you actually have the North Pole in the center of the map. So for those of you that do not know where the North Pole is, in this case, it's actually in the center of the map, which usually is not the case. The entire purple area is area that's underlain by permafrost. Some areas have continuous permafrost, other areas have less continuous permafrost, more sporadic spots, which is further south. Currently, about 24% of the northern hemisphere land surface is underlain by permafrost. So that's a really large area that has permafrost. And the other really important thing here to note is that in permafrost, there's a lot of organic material because the remnants of plant and animal inputs were conserved and stored in permafrost for thousands of years. The picture to the left shows the bone of an animal that lived more than 14,000 years ago. And to the right, you see plant roots. They are maybe a half a meter or a meter long, and those plant roots are also thousands of years old. So there's a lot of organic material that's stored in permafrost, and so we kind of can call it a freezer, an underground freezer of carbon. And when you look at this number, it tells you that there's a lot of carbon in there. So to translate this, there's 1,515 zeros grams of carbon in permafrost, which is about 1,500 times 10 to the order of 15 grams of carbon, or much easier, 1 petagram of carbon. So it's just a lot of carbon, and it's about twice as much as we currently have in the atmosphere. Arctic temperatures are increasing. We all know this, and it's increasing much faster than in the rest of the world. And this map to the left shows Alaska, and the green dots represent places where permafrost temperature is being measured. And the graph to the right shows how these temperatures have increased over the last 40 years. So in each of the locations, we have observed that permafrost temperature is increasing. And the implications for that are that if we have increasing temperature, we have an increase in thawing of permafrost, and this will engage more microbes to decompose the organic material that's stored underground, and this will release carbon dioxide and methane to the atmosphere. Both are greenhouse gases, and if we have more greenhouse gases in the atmosphere, this will in turn again increase temperatures. So this is a chain reaction that has already started, and once it has started, it's really hard to stop it. There are multiple additional sources that impact whether we have more carbon dioxide or methane coming out of permafrost. It's hard to see on the left, but it's one of these really big ice wedges. So if that ice melts, you have maybe a really high soil moisture content, and then the microbes will be releasing more methane in regard compared to carbon dioxide. The middle graph shows plant biomass, which is also increasing at this point because of warmer temperatures. But the question is how long and how much will plants offset some of that additional carbon that has been or that is being released by microbes. And to the right, we see disturbances. In this case, it's a big tundra fire that occurred 2 years ago. And this is a very unknown, unpredictable cause of disturbance that could add a lot of extra carbon to the atmosphere. For the global context, currently our knowledge is that we say that by the end of this century, we estimate that about 1 petagram of carbon could be released from permafrost, which is equal to the amount of carbon that's being released currently by land use change. So those are really big numbers. When we, however, put this in another context, how much emissions come out from the burning of fossil fuels, it's a smaller amount because there's 10 times more carbon being emitted by the burning of fossil fuels currently. And the global climate models currently do not include permafrost carbon interactions. And given the size of this permafrost carbon pool, even a really small amount coming out of permafrost will have really huge implications and accelerate climate change.
Thank you. I've been reminded I forgot to introduce myself. I'm Larry Hamilton from the University of New Hampshire. In Dr. Shadle's presentation, you saw us with the first description of what she describes as a chain reaction, this sort of self-reinforcing process of Arctic change, by which a little bit of change at first causes more change, and you can get an effect that happens very quickly on human terms, but it's not really reversible on human timescales. And I think you'll hear more about such things in our next presentation by Dr. Ted Scambus from the National Snow and Ice Data Center.
Thanks, Larry. So loss of land ice from the Arctic, fast and getting faster. It's another way that the Arctic is going to come to everybody's backyard one way or another over the next century. I think you heard from Christina how the Arctic has an impact on the atmosphere. We're about to talk about an impact on the ocean. And I think you'll be interested to hear what Jennifer Francis has to say next about that system, the weather and climate. And then our remaining speakers will talk quite a bit about the human impacts for the Arctic. It's warmer in the Arctic already, and in fact, the Arctic has already surpassed the 2 degrees C limit for the Paris Accord, the target that they had in mind. And that means that the rest of the world can't really get as warm as 2 degrees C if we intend to keep things within the bounds that were set by consideration of that the climate changes that are likely with the amount of greenhouse gases that we're likely to emit. It's faster, and by that I mean that all the glaciers in the Greenland ice sheet, that's the land ice component in the Arctic, that all of the glaciers that surround the Alaskan southeastern coast, other parts of the far north, they're flowing faster in general and retreating quite a bit as well. It's also wetter in that runoff from the Greenland ice sheet has doubled since the 1980s and contributing quite a bit to sea level rise. So I thought this was a fairly dramatic graph to show you. And one of the things I want you to take away from this, first of all, that clearly there's a declining trend in terms of the mass remaining on Greenland and being contributed to the oceans. And secondly, that we know this answer fairly well, that there's not a whole lot of doubt about where the trend is or our ability to measure it. Each of these oscillations has to do with the annual cycle of snowfall and then snow melt on Greenland, coupled with the ice flow, the actual dynamic component of flow off of Greenland. So you can see that although there may be variations from year to year, this is 2012, the record year, it was sort of a slight decline in the rate in the following year. I think we'll also see that this year that we're in right now may not see much of a decline in particular for this last summer. However, the overall trend is unequivocally towards greater ice loss. I wanted to show this animation. Oops. It's not going to let me do that.
Yes, and I actually
because I want to show you where in Greenland the mass is being lost in particular. What we're seeing is that in particular along the southern coast, and you'll see both these sides get quite tinted as we go forward. You're seeing a tremendous amount of loss in terms of meters of water equivalent coming off of the ice sheet. At the very end in the center, you'll see some pale, I'm not sure what color they'll turn out to be in this projection, probably slightly bluish. There are some snowfall in the center of Greenland, but by no means is that compensating for the loss around the perimeter. Here's another, maybe more grabbing visual effect. This is Greenland's largest glacier, Mount Thawing. And you can see here, this 6 mile wide ice front has retreated almost into the horizon, and we're at 20,000 feet in both of these pictures. So you can see there's been a tremendous change in the coastline of Greenland as this ice sheet undergoes this high amount of melting. Same thing in Alaska, and this I thought was astonishing. Alaska's Glacier Bay, that's the same shot, same area, completely vegetated now, and the glacier, what's left of it, is way up in the back of the fjord. That's happening all over Alaska. So what does this all mean in terms of sea level rise? Well, glaciers around the world have been contributing to sea level rise for quite a while now. But over the last couple of decades, the Greenland contribution has basically matched it. The fact that these slopes are nearly parallel in the last decade shows that Greenland has now reached the point where it's contributing as much to sea level rise as glaciers on Earth. Antarctica, although a much bigger mass of ice, is not yet at that sort of a pace. About 100 billion tons here, about 250 billion tons for both of these. And so what does the future hold in terms of sea level rise? Well, here you can see both our best record from the past for sea level rise, and in this last century, about 1.5 to 1.9 centimeters per decade. And decade is the right way to measure sea level rise because interannually there are quite a bit of variations associated with things like El Nino and the amount of runoff of the world's major rivers. But what we're seeing now in the most recent decade is around 3.4 centimeters per decade. So it's already increased quite a bit from the century average from the 20th century. And now what the scenarios are showing us is that we can anticipate 4 to 9 centimeters per decade, quite a bit of an increase. A little washed out, but what I wanted to show you was that there's winners and losers in terms of this sea level rise gain for the coastline of the U.S. And that variation around the coast is, well, a variance associated with the local conditions and the local geology. So what you'll see is that along the eastern coast, we're actually going to see slightly more. Our average scenario in the year 2100 is 1 meter of sea level rise, globally average. You'll see that the East Coast has a slightly greater amount of sea level rise than that due to gravitational effects, which I can elaborate on later. Here in the Texas and Louisiana Gulf Coast, quite a bit greater impact from sea level rise, primarily because sediments in those areas are still consolidating, and so you're seeing coastal loss in terms of elevation. Along the west coast, not as bad. There's a tectonic effect here that's helping to mitigate some of the sea level rise. But what you can see in Alaska is that, in fact, maybe counterintuitively, the places that are the source of sea level rise, in fact, themselves don't suffer too much from sea level rise locally. And that's because there's a gravitational effect. By losing so many billions of tons of mass, you actually don't draw the ocean back up onto the coastline as much as you used to. And so you're seeing sort of a shedding of mass from that part of the world to the rest of the world's oceans. Thanks very much.
Thank you. Yeah, in our surveys, it's clear the general public does not understand the difference between land and sea ice. That land ice, such as the glaciers and ice sheets that Ted was describing, has potentially dramatic effects on sea level, whereas sea ice, which is frozen seawater, really does not. However, they do have on the surveys this concept that Arctic warming is going to affect their weather. And I think they get that partly from more and better news coverage, including the nightly TV weather people. But going back just a step further, a lot of that owes to the first the research and second the communication efforts of our next speaker, Dr. Jennifer Francis from Rutgers University, who will be talking about weather.
Harvey, Irma, Maria, Irene, and Sandy. These are just some of the very unruly tropical storms that we've been dealing with in the last few years. And how are they unruly? We've had record rainfall, we've had record intensification of these storms, and we've had some really bizarre tracks. So the question is that I'm posing today is whether the Arctic and the rapid melting of the Arctic and warming has anything to do with it. I'd say there's no doubt about it. There are things we know. We know that the loss of ice and snow have darkened the planet on the whole. We've lost a lot of sea ice. We've lost land ice, as Ted just told you. And both of those things are making the Earth darker. When the Earth gets darker, it absorbs more sun's energy. So that is actually exacerbating global warming. One study estimated that extra warming to be about 25%. So about a quarter of our global warming is happening because we're losing the Earth's mirror. And because we're warming the Earth faster by losing this ice in the Arctic, we're putting more heat into the atmosphere. We're warming the oceans more. And both of those things mean that we put more moisture into the atmosphere, more water vapor. All of these things provide more fuel for storms, not just tropical storms, but all storms. Another way the Arctic is affecting the destruction by tropical storms, as Ted just mentioned, is the loss of land ice. So because we're losing all this ice in the Arctic, we're contributing about half of sea level rise. And when we have higher sea level rise, the storm surges brought by tropical storms are going to do more damage, and the storm waves brought by that tropical storm are also going to do more damage because they're rising, they're coming in on a higher ocean. So what's not quite so certain, and this is really the edge of research right now, is whether the Arctic is also affecting the winds that steer the storms. This gets to the tracks of these storms. Think Sandy, think Harvey. So this effect of having more moisture, we saw in Irene in 2011, where it brought unprecedented flooding to places like Vermont, where you don't usually think of tropical storms having a big impact. You can see that graphic on the right there showing about 9 inches of rain fell in Vermont from this tropical storm. Irma, just this year, we saw over 20 inches of rain fall in Florida. And of course, Harvey, we saw something like 50 inches of rain fall in some places in Texas. You can see it's been also associated with very warm ocean temperatures. The graph on the upper right there showing the differences from normal of the ocean temperatures being roughly 2 degrees Celsius warmer than normal. And of course, we know that led to some pretty horrific flooding there. So getting back to the Arctic, we know that the sea ice is disappearing. Everybody's heard about that. This is showing how the ice thickness, the sea ice thickness floating on the Arctic Ocean has been changing since the late 1970s. And what you see very clearly, you can see the scale there showing you how thick that ice is. The thickest ice is almost gone. And associated with losing all that ice is a very dramatic warming of the Arctic, as you've already heard. The Arctic is warming at least twice as fast as anywhere else on the planet. And what is that doing? We call this effect Arctic amplification. And there are 3 effects of this rapidly warming Arctic that recent research is suggesting is affecting the paths of tropical storms. So one of the effects is that it's weakening the upper level winds in summertime and in wintertime, but of course tropical storms are mostly in the summer and fall. We also think that the rapid warming of the Arctic, this Arctic amplification, is causing the jet stream, the storm steering winds in the upper atmosphere are becoming wavier. That is, they're taking bigger swings north and south. And we also know from recent work that in the summertime over continents, we're seeing these waves in the jet stream become stuck in place, becoming stagnant. Now, all of these things affect the paths of tropical storms. So here's just one recent research result suggesting that, in fact, in the future, we can expect to see these upper level winds to weaken even more. So this graph here is showing latitude on the vertical scale, and there's a map there that shows you where that latitude maps onto North America. The blue line there, that squiggly blue line, is telling you it's negative numbers over most of North America, suggesting that in the future, we're expecting to see these westerly winds in the upper levels of the atmosphere get even weaker than they already have. What does that mean? Think Harvey. Harvey came into Texas over Houston. There were no winds up in the upper atmosphere to speak of, and so it stayed in one place for days and days and days and resulted in that rainfall being right about here in some places. Also on that graph, the red squiggly line there is a measure of how wavy the jet stream is. What do you notice? You see that there's a big peak, and this is in August. In the future, we expect right over North America, the waviness of the jet stream is expected to increase. Of course, this is from a model, but it's a very consistent result that we find. This is very new work. There's also evidence that we're going to see these wavier patterns over North America increase. This happens to be the jet stream pattern that was in place when Irene came along in 2011. And what do you notice? This big dip in the jet stream. Irene rode those waves right up into Vermont, and this is a very similar pattern to what we saw when Sandy came along. And in that case of Sandy, we had a very bizarre wind pattern up over Labrador that brought easterly winds and drove Sandy right into New Jersey. Now we expect these wavy patterns to happen more often in the future. We have evidence that suggests that's already happening, and the models are suggesting it's going to happen even more. So you should expect to see more bizarre storms like Harvey getting stuck in place, or bizarre tracks like Sandy going left instead of right. There's also recent work suggesting that these waves in the jet stream are going to get stuck in place. They're going to become more stagnant, especially in the summer, especially over continents. So these are all reasons that we expect that we're going to see more bizarre, more unruly type tropical storms happening in the future. And why do we care about this? Well, some of it's obvious, but if we can predict how these extremes are going to change in the future, we can help planners, we can help decision makers get ready. We expect there to be higher risks in the future from these tropical storms and pretty much all storms. And that, if we can understand how that's going to happen, we can help communities prepare for these shifts in extremes as we understand better where they're going to happen, maybe how often those extremes are going to happen in the future. We can also start thinking about how we're going to help communities recover from these sources. Repetitive flooding events, for example. Houston just had a lot of damage from flooding, but it's not the first time that's happened. In fact, it's happened quite often. Should we rebuild in some of these places that get flooded out repetitively? It's a question that we need to ask because we're spending a lot of our tax dollars on rebuilding communities that have been destroyed over and over again. Thank you.
Okay, and from our last three speakers, you've heard about thawing permafrost, about melting land ice affecting sea level, and about increasing storm intensity. And there's some places where all three of those things come together. One of those places are coastal communities, the indigenous villages and towns in Arctic parts of Alaska, and where you have the town may itself be built on permafrost, it's at a low elevation, just barely above waves. And they're increasingly subject to severe storms that are no longer covered by sea ice. So our next speaker, Elizabeth Marino from Oregon State University, will be talking about those communities and placing them in a larger context.
Thank you, Larry, and thank you all for coming and staying with us through this afternoon. I appreciate all of your attention very much. So as we've heard, warming in the Arctic is happening at a faster rate than the rest of the world. Warming, as we have also heard, thaws permafrost and creates erosion. Warming makes storms more violent. Warming makes gluten bad for you. But warming is changing the coastline of Alaska permanently. And a changing coastline and bigger storms means that flooding is happening more often and happening sometimes in worse cases in Alaska. And it's creating disasters. But what we know now is that disaster policy isn't adapting quickly enough to handle these permanent changes. Now, researchers know that communities most vulnerable to disasters are consistently made up of politically marginalized groups or populations. In Alaska, for example, 86% of Alaska Native communities experience some problems with erosion and flooding. And there are a number of really complex reasons for this, which I can talk about more in the question and answer section. But now I want to focus on the fact that some of these communities are going to need to relocate in order to ensure their safety and sustainability in the future. And I'm going to show you just one picture of one of those communities today. This is a picture of Shishmaruk, Alaska. It was taken by a community member there named Dennis Davis. And when I started to work in Shishmaruk about a decade ago, I used to say in presentations that the community was about a half mile wide. And I've had to edit that now and say that it's closer to a quarter of a mile wide. And that just gives you some indication of how rapid erosion has been in Shishmaruk over the last 10 years. I also want to take this moment to point out to you that a community member of Shishmaruk, Darlene Top 2 Turner, is in the audience. And so if any of you want to talk to her after this panel about what it's actually like to live in that community, she's told me I can say she's available to comment. But the biggest point that I want to make here today is that disaster policy in the U.S. is not really set up to handle disappearing coastlines or repetitive flooding. Because for the most part, and by that I mean the majority of FEMA's budget goes towards rebuilding, and it really treats disasters as one-off phenomena, right? Or it treats flooding as an exception to the rule. And we know that when we're talking about climate change, we're talking about the rules themselves changing. And we're talking about flooding that might become the new normal. And there are relatively few policy mechanisms or funding mechanisms that really can be directed towards helping communities to relocate. One exception to this is something called the voluntary buyout process. This is a hazard mitigation tool that's been used post-Sandy. It was used probably more than it ever has been, and now it's being deployed in Texas right now. And this is a tool that's used to buy back properties that flood repetitively. But why doesn't this process, this voluntary buyout process, why doesn't it work in Alaska? When buyouts are used, they give people pre-storm market value to individual households. And this process does not consider a community or community infrastructure as a whole. It can also only be used when an individual actually owns their own home. In Alaska, it's really challenging to establish market value in a place that's as rural as Shishmaruk or Utah. And additionally, if market value can be established, it's often not enough to cover the cost of rebuilding a new house. Also, the policy doesn't fit communities who have renters and owners and all income types of people who need to remain together, who depend on each other to make that community function. And all of these conditions make this policy ill-suited to tribal communities in particular, who are advocating to remain together and advocating to remain on traditional territory. Therefore, communities that are in Alaska and working towards relocation are forced to do so in this ad hoc manner. So they're forced to cobble together funding without having a clear policy pathway forward. I think what I want you to think about is how powerful of an example this is on how policy really is not working for marginalized communities. And this in turn makes these communities more vulnerable to climate change. And we can say, therefore, that this vulnerability is not circumstantial, right? But it's a patterned vulnerability. So what is the takeaway from all this? Here are the big numbers, right? Even though the coastline only accounts for 2% of global landmass, 10% of the global population lives along the coast. Most of the world's megacities are built in low elevation coastal zones. And we know that the population of the coast around the world is increasing. We also know that poor and politically marginalized communities are more likely to flood and more likely to experience long-term suffering once a flood happens. So, the elephant in the room is, if we can't move 600 people from Shishmaruk to the mainland in a way that is fair and equitable and protects their human rights and tribal sovereignty, then what are we going to do with the rest?
Thank you. These communities, I think, are often described as being on the front line of climate change. And if you see pictures like this, you understand why that is. Our next speaker, Dr. Henry Huntington of Huntington Consulting, will broaden the scope a bit further and also bring in not only the climate and physical and social impacts, but also some of the economic and perhaps geopolitical concerns that are raised.
Thanks, Larry. So the question that's up there is, does the Arctic lead or follow? To put that another way, to what extent can the Arctic shape its own destiny? And to what extent is the Arctic at the mercy of global geopolitics, global markets, and global climate change? I think this question is increasingly pertinent as conditions are changing rapidly, as you heard in several of the previous talks. Now, let me give some examples of what I mean by tension between leading and following. These are a couple of places I'll be mentioning. Can the Arctic lead in geopolitics? At the moment, 5 Arctic coastal states and 5 other countries are negotiating an agreement for the Central Arctic Ocean not to fish because we don't know enough about the ecosystem and about fish stocks to fish responsibly. It seems like a sensible action to take regarding in the conditions we have in the Arctic and what we know about the Arctic. Similarly, in the Bering Sea region, the US and Russia cooperate at a practical level in dealing with fisheries enforcement, search and rescue, and other matters in that region, regardless of what's happening between Moscow and Washington. Those are examples of leading. Following, we see Russia installing a military base on Franz Josef land and perhaps leading to some expectations that we're going to see a remilitarized Arctic and an expansion of conflict in that area. So is the Arctic going to become the next proxy site for some battles taking place elsewhere instead of being allowed to exist on its own? If we think about markets, we can look at fisheries management in Alaska, in Norway, and other places that are some of the best examples around the world of sound, sustainable fisheries management. Again, these regions are taking the conditions they find and acting accordingly on them and leading the way in terms of, if you look at globally, the state of fisheries management is abysmal. A few of the bright sparks are in the Arctic. On the other hand, I was at a wedding last Saturday and they served salmon. And to this Alaska snob, it was insipid farmed Atlantic salmon, which is horrible. And yet, whatever's happening with global markets for salmon and these farmed fish is indeed a threat to, say, the fisheries management that you can get in, say, Alaska, where in Bristol Bay in 1997 and 1998, the fisheries returns were way down. In many cases, that means fish anyway because we have a buck to make. In Bristol Bay, it meant stop fishing because we have a future to protect. There was no controversy among the fishermen about this. They took that action. Bristol Bay remains one of the richest fishing grounds for salmon in the world. And yet, regardless of how well they do that, we could face a challenge if the markets are undercut by something that happens elsewhere. In terms of climate, Savoga, Alaska, a small Yupik village, they have faced the later freeze up of sea ice in the fall. One thing they've done with that is to invent an entirely new whaling season. It used to be that they only went whaling in the spring. Now they go whaling in November, December, and January. So imagine being out in a small boat in the Bering Sea in December, and yet this seems like a good thing and it's a new opportunity for them. They've been able to innovate and create an opportunity. Kivalina, not far up the coast, hasn't caught a whale since 1995. The ice has been changing. It's no longer reliable. It's no longer safe to go out on the ice in the spring to get from the village to where the whales are. So sea ice change in both places with very different outcomes. Savoga leading the way through innovation. Kivalina just being a victim of things that are being forced from elsewhere. Similarly, Beth spoke about the response to coastal erosion and whether Alaska has a chance to lead in terms of innovating and finding ways to help communities like Shishmaref, or whether we're stuck following the patterns that are set in the lower 48 that really don't fit Alaska's needs and conditions. Now, the path we follow here is going to have very big consequences for the well-being of Arctic peoples, for the Arctic environment, for businesses in the Arctic, even for national security of Arctic countries. The question is, how do we foster peaceful relations, good governance, responsible resource use, environmental stewardship, and robust innovation? One idea I have is that we need to get the people who are interested in those outcomes, who are interested in the peaceful, healthy Arctic, to work together better. We don't often see that. We don't often see that the people who are involved in shipping, talking to the people in coastal communities, talking to the fishermen, talking to those who are interested in national security and so on, and recognizing that we may differ on certain aspects of just how we should or whether we should pursue offshore oil and gas, but surely none of us wants to go down a path of chaos and disorder. So how do we get people to recognize that common interest so we can take the Arctic on its own terms and again not use it as a proxy for other problems in other places? If we do that, I think we can take this common interest and build it not only across the Arctic, but also not only across sectors, but also outside the Arctic, with people in the lower 48, with people in Europe, China, and beyond, other places that are demonstrating an interest in the Arctic. It can be a source of tension, it could also be very much a source of collaboration and cooperation. If we're successful, I think we can turn my opening question around and ask how the regional and even global responses to the politics and economics and climate change. And in doing so, the Arctic has an opportunity, has the ability to chart its own course and not to let others decide its fate from afar. Thank
So, many Arctic experts now think what would have been a radical idea not much more than 10 years ago, that the Arctic Ocean will be ice-free in late summer before the middle of this century. And one can talk about what effect will that have on sea level and how the ocean currents will flow and what animals and plants will be able to live there. And also, even harder to understand what will happen to the people, because an ice-free Arctic Ocean is outside of human experience. It's a new system state. And our final speaker today is going to address how do you think about something like that? How do the people most directly affected think about that? This is Amy Lauren Lovecraft from the University of Alaska Fairbanks on the Arctic in 2050.
Hi, it's a pleasure to be here today, and thank you very much for coming. So I'm ending our set of presentations with a talk about scenarios. Scenarios research is an established method to reduce risk in near-term decision-making by researching the future. Now, the scenarios I'm talking about are not visions of what we want, nor are they predictions of what will happen. They are plausible explanations of the future that can increase our capacity to determine and prioritize those variables most important to monitor over time. So please, and you may want to close your eyes for this, imagine that you are walking into a room of doors, hundreds of doors. Each door represents a different future in 2050. Behind each door is a distinct future Arctic. Each possible future Arctic is a combination of multiple factors, such as greenhouse gas emissions, glacial melt, weather patterns, community livelihoods, and political economic trends. Each of these doors represents a scenario, an imagined future based on what we know today. So, what combination will be behind the door you choose? Will the Arctic in 2050 still function as the Earth's refrigerator to stabilize climate and weather patterns? Will it provide seasonal sea ice for hunters, industry, and marine life? Each of the prior speakers has presented key aspects of the Arctic's ability to provide services, what humans get from their environment. For example, sea ice provides a stable platform for industry and subsistence hunting. Permafrost keeps food cold and preserved in ice cellars throughout the year in rural communities. But as we have seen, the Arctic also has lessons to teach us as it changes. The research and science of these speakers and other dedicated people like them is fundamental to understand what we know about the Arctic and to predict the changes most likely. But we need to consider carefully how all of these different changes mentioned today will interact with each other on their future trajectories. In order to make decisions, we need to not only imagine the future of permafrost, but also other indicators related to a changing Arctic, such as economic development, shifting seasonality, sociocultural changes, global politics, national security. Now, prediction is inherently difficult. Just ask anyone betting on horses or buying stocks in technology companies. When we don't know what's going to happen in the future, when there is uncertainty surrounding our options, we imagine, using our best available science, what the future will look like. We ask 2050, what if? What if sea level rise causes massive relocation across the US coasts? What if sea ice diminishes to such an extent shipping is possible 9 months out of the year in the Arctic? What if rising global tensions creates a more militarized Arctic Ocean? This process of informed imagination to guide decisions is the power of scenarios. So thinking about the future through scenarios methods enhances the ability of an organization or a government to make effective decisions under conditions of uncertainty. The more we can learn about the Arctic and the consequences of its melting and thawing from multiple informed perspectives in the near term, the better information we will have for long-term decision making. We have the capacity now to direct the future of the Arctic. It is not a lost cause. A scientifically rigorous look at the future informs how research can be directed at policy concerns that matter to all of us. For example, at the global level, the Arctic Council has recognized the importance of scenarios in the adaptation actions in a changing Arctic reports. From a local perspective, my team recently wrapped 2 participatory scenarios projects focused on what Arctic resident experts think about the future of their own communities. And an advantage of the scenarios methodology is that it can be scaled in relation to what kind of question you're asking. For example, in these projects limited to Arctic Alaska, we asked what is required for healthy, sustainable communities in 2040. At other scales, futures thinking in relation to climate change can be used for evaluating global scenarios of warming, national planning for Arctic security, regional approaches to increased storminess, or village-level concerns with community resilience, such as will my ice cellar melt or thaw, depending on which element of it is going to go. And what does that mean, right, if I have to then find some way to refrigerate food? So we know the Arctic is facing a suite of interconnected transformations. In order to respond to these different, rapid, and often surprising changes, decision makers need to consider now what the current trajectories of the key drivers will be by 2050. What will be on the other side of that door? It's interesting to note that nearly a decade ago, there was an Arctic Open Science meeting in Miami, Florida. Maybe some of you were there. It brought together around 700 people from 16 countries to discuss the state of the Arctic in 2010. Sea ice decline, warming, and weather pattern changes have now exceeded most of the models from just a decade ago. Search, who's sponsoring this suite of talks, is currently designing the next Arctic meeting for 2019. We are focused on integrating multiple data streams and exploring the future state of the Arctic in 2050 to produce policy-relevant knowledge. So in sum, scenarios enable communities and governments to synthesize information from multiple sources to minimize the risks presented here that are emerging from a thawing Arctic. By anticipating changes and making action today, right, scenarios can result in effective proactive adaptation rather than potentially costly passive responses to change. Thank you.
Okay, and I would like to thank all our panelists. I think it's a strikingly well unified. I didn't really realize that until it was unfolding. It all goes together very well. And it's also, for those of you who know academics, very impressive that everybody voluntarily kept to their allotted time because there's obviously vastly more knowledge here in the panel than what they could give in a 6-minute summary. So our schedule now is we'll open it up for general questions. I'll first of all ask the journalists in the audience if they have questions, and then anybody, any discussion. And then we'll adjourn formally at 4:30 and informally have a light reception outside. So, yes.
Seth Warren, Associated Press. Actually, mostly let's start with Christina. You talked about the amount of, that by the end of the century, you're looking at about 1 petagram of thawing, of carbon release from permafrost. What's the rate now, and can you walk us through projections over, now, whatever, 2050, 2030, whatever, just put this all in more perspective.
So most of the carbon is still frozen currently, but we do observe annual carbon release already is uncertain, but the estimated amount per year currently is about 0.3 petagrams of carbon. So that's much less, of course, than 1 full petagram, but if we continue the path we are on right now, the 1 petagram by the end of the century might be a very conservative estimate.
In terms of if it's 0.3 petagrams now, was there any release 30 years ago, 20 years ago? I mean, I just put this in sort of historical perspective.
There was no carbon release 30, 40 years ago, or a negligible small amount given that most of the carbon was locked down frozen. There's always some in and out happening because of active layer and thawing in the summer, but that's not accounted for in these numbers.
And I guess the projections, is it supposed to be logarithmic, or I mean, how are these projections supposed to be? Is it steps and stairs, or is it a lot like what we've seen in sea ice, big steps and then, or is it more of a smooth chart,
The anticipated release is a gradual release, and it very much depends on any additional carbon, any additional greenhouse gases that will be released to the atmosphere. So it could be much more, but it is not expected to be a bomb release. It is expected to be a gradual release over time, more on the linear side.
Okay, questions? Open up to anybody who's curious. Yes.
Joe Dudley, University of Alaska Fairbanks Institute of Arctic Biology. I think an example came up of why we have problems with political will. To have an Arctic meeting in Miami just shows that, people are willing to talk about the problem, they're not willing to confront it. They're not willing to go to the area to see what the impacts are, to see the people. We're willing to rebuild barrier islands in tourist areas on North Carolina, repeatedly, million-dollar mansions. We won't deal with communities whose lands are eroding away in the Arctic. I think we need to get more organized. There is more attention going to the Arctic. Carnival Cruise Lines, all the places that are no longer have places to go to in the Caribbean are already scouting areas in northern Canada and Alaska to move their operations. These are going to have huge impacts. These plus commercial shipping through the Northwest Passage are going to have tremendous impacts on coastal communities. Huge amounts of pollution, garbage, toxic waste are going to accompany these industrial and commercial operations. We need to pay attention to the needs and the rights of the people who live in those areas and not let them be overwhelmed by the new opening oil frontiers in the Arctic Sea, the new commercial shipping traffic lines, the new tourism venues, and to ensure they can keep their traditional cultures, values, and property rights in the face of commercial industrial encroachment.
Thank you. Just on the topic of Greenland and Miami, I wonder if Ted would like to say something.
First of all, we here are willing to confront the Arctic, and I think everybody here has been there and tried to look at the problem firsthand as well as through satellite data or whatever data we can get for the human impacts. Most definitely, it's important to have these meetings in places around the coastlines of the U.S. because we need, and like Washington, D.C., because we need to get folks thinking locally about how the Arctic is going to impact their community. And I think on both sides, actually, of this split table, you saw how the Arctic is going to reach out and affect the rest of the nation and the rest of the world. It's a challenge to get people to think about this far-off place as having an effect on their back door or their favorite beach, but it's true. And I think meetings in these places could only help.
Any other panelists want to respond?
Anchorage is on the coast too.
Yes, and I think I was reading about storm surge warnings in North Carolina today, so relevant to the hurricane is which one is Maria, but there's also Lee is out there. Okay. Okay. Yes.
So speaking of hurricanes, earlier today, there was a NOAA modeling prediction webinar where the Texas State climatologist John was talking about climate connections in Arctic, and he addressed the concept of Arctic amplification. And what he said with that is one possibility, but it also conflicts with the concept of the tropics moving more northward with climate change, and therefore you would not have the jet stream effects on, because the jet stream doesn't affect the tropics as much. I'm wondering, have you looked into the interaction of the wavier jet stream and along with the widening tropics, and what sort of happens when you've got both?
Sure. So there's obviously many changes happening in the climate system besides what's going on in the Arctic, including in the tropics. We do see that the tropics are expanding towards the poles as the Earth warms, but there have been studies that have shown that if you take a model and you just remove the sea ice, for example, we do see that in the summertime over continents, the jet streams do move northward. So this is consistent with what we expect to happen as a result of the tropical warming too. So the two are both sort of pushing things in the same direction. But we do see this effect of the Arctic warming in the summertime also. In particular, we think the summer effect is because we're losing the snow cover. We haven't talked about that today, but the snow cover is disappearing much more rapidly in the springtime, and that's allowing the high northern land areas to warm up faster, dry out faster, and so we're seeing the effects of the rapidly warming Arctic really happening on the land and not so much over the center of the Arctic. So this is kind of giving summer a jump start over the continents and allowing that jet to move farther north just because of that snow disappearing. So in this particular case, both of those things are kind of pushing in the same direction.
Oh. Yes.
Rick Weiss from AAAS. Two questions. One is the statistic, I think, is from Jennifer, that 2% of the land mass is coastal, but 10% of the people live there. How do you define coastal, just so we know how to use that properly? Is there a width we're talking about? And secondly, the statistic about maybe going up to 5 centimeters per decade increase in sea level rise. As a communicator, I keep struggling with how to figure out how to convince people that that matters, if it matters, because it sounds small. It's a couple inches in a decade. So how can you folks deal with the question of who cares, really, in 2 inches?
I can address that second part. For example, the damage that Sandy did in the New York area has been estimated to be $2 billion more because of the sea level rise over the last 50 years or so. So just the 9 inches that have been observed in the New York area has caused that much more dollar damage because of one storm. So it sounds like a little, but it has a big impact.
And you're placing these storm surges and other events on a higher platform. So it's not that people have to run from sea level rise, it's what happens to the storms, the augmentation that you see for waves and storm surges around the entire coast.
The low elevation coastal zone is typically defined as anything 10 meters or lower, above sea level or lower.
By elevation, outside,
By elevation.
inland ones.
And I mean, the other thing about sea level rise, which is something that I'm interested in more, because if you look at these places around the world that are experiencing sort of the places that become the face of climate change, like Tuvalu and Maldives and places like that, is that sea level isn't rising the same uniformly around the globe as well. So it is affecting particular places in bigger ways than this like global average might be.
Can I go on with that? That was the point of the last map that I showed, which focused on the U.S. The broader picture is an amplification of what we saw with Alaska getting away with a smaller amount of sea level rise. Both poles lose a tremendous amount of mass in the next century in the form of ice melting and flowing into the ocean. So what that means is that tropical and temperate latitudes are going to take up a higher fraction of the global average sea level rise because we're actually changing how mass is distributed on the planet through global climate change. So places like Maldives, Tuvalu, or coastlines of Florida and California are going to see, well, California has a tectonic get out of jail free card, but they're going to see a greater increase than the global average.
And I just want to say one more thing too, to interject kind of the social scientific view into these conversations, is that sea level also interacts with human decision making. So with the coastline of Louisiana, for example, you have all of this oil and gas infrastructure that compounds the problem, that destroys the marshland, that, and then so
Plus the extraction.
and extraction absolutely that lowers the land, right? So you just have all of these features interacting to create these particularly vulnerable places. It's an important thing to remember.
Go back to the sea level numbers you're talking about, 4 or 5 centimeters per decade.
4 to 9.
4 to 9, okay. Because that makes a little, because we hear people like Johansson talking about more than a meter. You keep hearing a meter sea level rise by 2100. And 4 to 9 doesn't sound quite like it jives. It sounds a little under, or a lot under if you're in the 4 range.
So that was a middle of the road scenario that was sort of centered on this 1 meter plus or minus estimate for sea level rise at the end of the century. There are several things that could trigger a greater than 1 meter net global average. One of them, how fast we're going to hit global greenhouse gases, how hard we're going to force the climate system. Another one has to do with exactly how the ice sheets are going to respond in detail. Are they simply going to melt away like an ice cube in the sun, or are there going to be dynamic effects that actually accelerate the rate at which ice is removed from Antarctica or Greenland? And both those things are, well, they're less unknown than they used to be. There's a lot of models out there that are beginning to explore all this stuff. I don't like to say that we need to study things more because we always want to study things more. But the point is that there are probably some surprises left, and so it's only rational to talk about middle of the road scenarios and take a look at what the worst case might be if things go badly for things like ice cliff failure or the effects that new fjords being opened up around Greenland have on the rate of sea level rise.
So the 4 to 9 still has some ice sheet loss.
Yes.
Because that was one of the criticisms of IPCC.
Yes.
Or didn't have any ice sheet loss.
Yes.
This includes some,
Yes.
but you'd say it's sort of a moderate amount.
That's right.
Just to follow up on your talk about potential accelerating effects that may not be necessarily foreseeable, that brought to mind, and throughout the presentation, I was thinking about sort of black swan events like the Younger Dryas, for example, and how that could really, really mess things up. Are those, to what extent can we quantify that sort of unknown unknown? Is there any sort of modeling that's being done? Things that could produce really rapid.
Some papers that have discussed that along those lines. In other words, just exactly how fast do all the existing glaciers need to move in order to unload the meters worth of sea level rise? One of the takeaway messages that I've gotten from the top of the ocean is really, really big. And so you can lose, you put 1 billion tons, many billions of tons into it, and only get a small amount of sea level rise. But the, I lost my place now. Yeah. Gosh darn it. I had a great answer to
We can come back. We will hear this great answer later. In the meantime, anybody else want to take another question? Yes.
To what extent, so I know in Greenland, for example, they had huge area on fire, and I know that when this is, to what extent is this factored into CO2 emission releases? Because I know the heat from that fire being burned is releasing emissions that maybe people didn't account for.
It's really part and parcel of changes in permafrost and the amount of carbon that's stored in the lands in the Arctic. And, Christina, you already showed a large peak fire. It's unusual to have this happen in Greenland. It has to do with, kind of percent losing snow earlier in the Arctic, that you get a dry land surface early in the season. But that fire in Greenland is important to the folks that live there. Not a big factor, not thought to be a big factor in terms of overall CO2 release as we go down decades or whatever. More important to watch what happened in Canada, Alaska, and Siberian permafrost areas.
Well, there's potentially a lot of additional carbon coming out, and the problem maybe is that people do not necessarily live where those fires occur, so we may not be right there when it happens. So measurements are maybe not always available. It may take some while until we quantify how much of the carbon has been lost. But we certainly know that the upper surface layer in permafrost contains the highest amount of carbon usually. So if that all gets released in a chunk, that's a really big number. And we cannot foresee how much it will be, but it is a lot. We know that. And it takes away the insulation too, which will accelerate thawing deeper layers, and that's an additional wild card.
Yes.
I have a pretty basic question that may be well known to specialists, but not to the general public like me. But from the last glaciation, large amounts of the northern hemisphere are still seeing a lot of sort of isostatic rebound from that. And I was wondering, do the climate models that deal with sea level rise account for changes in the land surface because of those effects, or are they just considered to be negligible because there's not nearly as much ice as there would have been during glaciation?
Let's repeat your question, because I'm still trying to come up with that last They don't in general. In fact, when we talk about the amount of melting that contributes to sea level rise, what we're doing really underplays how many different things are going to go on as we add water from the ice sheets into sea level rise. We talked about isostatic rebound, inundation of coastal areas. Some of those things are really thoroughly accounted for. It's the area of the ocean spreading the amount of water that came off the ice sheet evenly everywhere. So when we say, you may not have picked up on the number, but 362 billion tons is about a millimeter of sea level rise. That value has to do with the area of the current ocean and not accounting for anything having to do with local land motion around the coastline. There's lots of local effects. There's also global effects having to do with how that plays out. Black swan. This whole thing is a black swan event for the Earth, and we've never gone through this kind of forcing on the climate system. So there are lots of surprises that we can't learn from understanding the past better, because we're pushing the system in a different way now by driving the atmosphere first, rather than having it be a slow change due to changes in the cycle and gradual responses to the system. So, so it's hard to know what's, say, buried in the system as it unfolds over the next century.
I just want to use that.
Please go ahead.
Oh, I was just going to say that all the language that's being used here is very much in line with this need to direct science today based on careful envisioning of what the future may hold, right? And one of the things that scenarios does is it allows for multiple kinds of information, not just computer modeling, but for example, indigenous knowledge, which may go back thousands of years, It also allows for marginalized knowledge. In other words, you don't need a PhD to participate in what your lived experience in Southern Louisiana teaches you over 50 years. So this ability to imagine with really diverse voices what the future might look like is something that can help catch or think about black swans that might be missed by those of us who sit in offices running models. So the scenarios can help think through black swans, wild cards, and as Ted points out, we're working in an area where our paleoclimate data doesn't help us. So we really need this human element of conceptualizing what the future might look like and think about those different doors. Because, right, the closer we get to 2050, the faster all of the warming happens and the melting and thawing accelerates, the fewer and fewer doors that are going to be available to us, right? We're going to start shutting out our options as we get closer to tipping points with sea ice and other elements that are helping at least seasonally to hold the system in place.
Anything else? All right, another question. Yes.
I was wondering if the panel could expand on some of the human dimension of this problem. So we talked about policy implications, we talked about places where the Arctic reading or following, and for preparedness and risk management, either from a very hands-on disaster management or preparedness and response point of view, by FEMA or the Coast Guard or whoever. How do we move forward? So those are all, you raised the issues. I guess the question is, what are possible solutions on all those levels that could be implemented? One way we heard is potentially thinking about scenarios so that we're more ready, we thought about it ahead of time. But what are some other actionable things potentially that we can follow?
That's a really good question. I guess the panel has been focused on climate change and so on, but a lot of these emergency responses don't necessarily have to be to a climate event. It could be to a weather event if you want to make that distinction, but they could also be to something like a ship running aground and spilling oil, and all of a sudden people have to respond very quickly. As we know, the Coast Guard has a wonderful base in Kodiak. That's a long way away from anywhere in the northern Bering Sea or beyond that. And so figuring out ways to be able to deal with these things, again, I think we have to start thinking beyond the standard responses that we employ in more populated areas. The Coast Guard is 2 days away. What can the people in a local community do? Well, instantly we run up against things about OSHA and hazmat and handling oil and all kinds of problems. So the advice seems to be, just stay away from it and wait. In one sense, that sounds like really good advice. In another sense, that sounds really frustrating and maybe not terribly practical. What are the things we can do to enhance some of the capacities we have in the region? The alternative would be lovely to say the U.S. should build a few more really good icebreakers. We should figure out how to have a Coast Guard presence here. You can see the dollar costs mounting up until they're in numbers like Ted's for the tons of loss from Greenland. There seem to be other things. So how can we find ways that we can enhance the ability of people who are already there and the systems who are already there to be able to handle something? It won't take care of everything, but it seems to me that's a pretty big untapped resource.
I'd like to add to what Henry just said because of Yvette's presentation, for example, Dr. Marino's presentation, so we know each other. You hear, and we know, right, both statistically and with geographic mapping, that many of these places that are going to be most greatly impacted tend to be locations where the poorest people live. Now, there are, of course, also these big resort homes. But there's a question related to how do we care for, and I don't mean that in a paternalistic or a nanny state sort of way, but based on what Henry just said, if we realize that a lot of these disasters, and I'm here thinking about due to climate, are going to happen in areas where people are already marginalized and relatively impoverished, if we can find ways to, for example, for policy, give them tools to help either mitigate or manage disasters that may come, you have, in fact, an economic opportunity that may empower local communities to manage things on their own, as opposed to always needing the first line response to come from the federal government. So I think, I won't go on about it, but there's some really interesting wrinkles in how we can meet the ideological concerns of a variety of different political stripes in ways that are simply going to assist low-lying areas and other regions, and that may in fact also spark some economic development.
I'm going to be a little less politically neutral. So, you know, I want to, there are many different ways you can answer this question depending on your scale of entry, right? So like at a global scale, we need to think about adaptation and cutting carbon as a global community in order to, you know, mitigate climate change as well as we can, right? On a national scale, I mean, we are losing all of the people in the federal government who are tasked to handle climate change adaptation. We're losing them, right? So that is a very, that is crippling our ability as a nation to think about things like how do we promote, you know, safe, reasonable, and fair retreat from the coast, right? And then on a very particular level, you can say things like amend the buyout process to include communities and not just be focused on the individual. And I will say, you know, and this is an area of work that people are getting into more now, but the buyout process is a really interesting one. It's what I brought up today. I encourage you all to watch it as it starts to become more and more in the news when we think about Florida and Texas and the implications from the hurricanes this season. But buyouts right now are based on market value of your house pre-storm. So if you need to adapt to climate change and you live in an $800,000 house, the federal government will give you $800,000. It's not just the federal government, it's complicated, but essentially that will happen, right? And if you live in a $40,000 house, the government will give you $40,000. So we should ask ourselves, do we want climate change adaptation to play out like that? Where the government gives the most money to people that have the most money, right? This is a question of this basic, you know, economic structure by which we have devised disaster policy. And I mean, that's, you know, how do you tackle that? I'm not sure, but I do know that as a social scientist that when we see forest relocation, for example, around the globe, it has really disastrous effects for certain communities, right? And I really don't want that to happen when we talk about the effects of climate change. So I think we're going to have to address some really hard questions. And it has, you know, at scale, it has like these big sort of ideological aspects to it, and then it has some really particular aspects to it, like what policies can be changed tomorrow that would make these processes more equitable. And, you know, fun social science. That's the other thing, because we just need people that are really digging into these policies to think about something.
So I'm going to put on a different hat right now. I'm on the planning board of our little coastal New England town. A lot of our town is very susceptible to hurricanes and the effects of sea level rise. Like most New England towns, change is a four-letter word, and I've been trying, as my position on the planning board and other committees in town, trying to wake up our town to the fact that we are very susceptible to these flooding events and these pretty catastrophic events. So one of the things we've discovered is that all of our pumps for the town's sewage are in the velocity zone. So they are in the velocity zone, which means that if we get a storm, FEMA has determined that they're in a place where the waves from the storm are going to influence that spot. So things like that people haven't thought about before, and just, you know, getting individual communities to realize that their infrastructure is really at risk. And what are we going to do about it? And so just, you know, at the local community level, trying to get people to start thinking about, you know, it's a ticking time bomb that we've got right there, and just trying to address things like that.
I would echo that with some experience from field work we're doing in Eastern Oregon, where climate change is sort of a word you can't say, but people are very aware that there are more fires than there used to be, and they're much more dangerous and more damaging. So the sort of back door is not mitigation at all, but it's adaptation. Are there steps you could do without mentioning climate change that would be, at least in the short and maybe even medium term, beneficial, increase resilience in the face of the fact that, yeah, it's getting drier and hotter water and we're having more fires. Or where I live in New Hampshire, flooding is the chief natural disaster. And that is exacerbated, of course by the seaward, but also by how you've developed the land, whether it's covered with permeable surfaces, whether you have a lot of development close to the riverbank or close to sea level. And so changes in infrastructure and zoning and planning, maybe insurance, and how municipalities look at these things are an entry point where you find that the main door is completely blocked by politics.
I just started sitting in a stewing since my friend behind me talked about where to have a meeting on the Arctic. A friendly amendment. Miami's absolutely the wrong place to have it. I think something like that. Actually, Miami's, in my view, is the right place. I chair a group called Arctic 21. Our mantra is the fate of Greenland is the fate of Miami. Miami holds all the politics. The Arctic holds very little politics of this country. I mean, Miami has a multiple effect. Florida has a multiple effect. So if you want to move policy in the Arctic, sea level rise. Miami's key. And if you watch, everybody see what the mayor of Miami said during the hurricane. It's absolutely time to talk about climate change. And when you move Florida, you move the country, you probably move the world. So I said, it's the purplest of states. I recommend Florida. Now, just one other comment. Recall that President Obama went for several days to Anchorage and the Arctic in order to draw attention. So he was listening. He hasn't been to Miami yet.
Well, I recognize it's easier to get politicians to go to Miami. That's why they hold the meetings in Miami and Orlando and San Diego. I recognize that. I'm just saying, I don't think it's right.
Henry.
I just have one further comment to Francis's question in terms of out-of-the-box thinking. So one of the things depends on how you look at the map. So one of the things we repeatedly hear in Alaska is, well, there's no deep water port. So where are you going to station anything? How could you deal with it? How could you take care of a big ship that was in trouble? And you look at the coast and it's all shallow and low-lying. And we think, what if this is a major problem? That only makes sense if you stop your map at the date line. Because in Providenia, Russia, just a few miles across the border, you have a spectacular natural deep water port. It seems like it would make eminently good sense to look at it in terms of the region. And I've even heard Russian shipping executives and others talk about it that way. And yet we don't. We talk, what can Alaska do, completely neglecting some of the assets and resources that we have just a little ways away. So how do we, again, in this lead or follow, do we follow the we can't talk to each other because of the Ukraine line? Or do we say, we're in this together in the Bering Strait. None of us wants to see a disaster. Let's pool our resources. You have a port. We have other stuff. Let's do what we can. So you're saying Seward stops short of the.
Okay, I think we have time maybe for one more question. Break for the day if anyone has one. Or anyone on the panel hasn't had the last word yet. Okay, if not, all right, there's a reception outside somewhere.